Now at number 5, CSEC Admats, June 2023, paper 2, question 5. All right, let's finish this. Question says, consider a toy truck moving along a miniature racing course with an acceleration given by this. All right, so we'll have to integrate to get velocity and integrate to get displacement. Simple. Where t is the time in seconds, assume that the speed of the toy truck is measured in centimeters per second. Outline how an equation for the speed of the truck will be found using the given equation for acceleration. So firstly, what you have to see is that acceleration is the rate of change of velocity, dv by dt. All right. I'll put another way, dv by dt is equal to the acceleration. And so the velocity is going to be the integral of the acceleration with respect to t. I think that is it. 1 mark. All right. Simple as that. And then they say, find the speed of a truck t seconds after t seconds. So here they didn't give me any conditions. So we have to assume that we have to make some assumptions. They didn't give us any conditions in terms of where it was to find our concept of integration. Because we're going to have to integrate. So we can maybe assume that when t equals 0, the velocity is 0. Consider a toy truck moving along an initial racing course with an acceleration of that. Where t is time in seconds. Assume that the speed of a toy truck is measured in outline or an equation. I guess we're going to have to assume, but once you integrate without limits, right? This is velocity. Just I'm telling you, the velocity is equal to the integral of acceleration. Integral of acceleration. So we're gonna end up doing that. You know, I want the speed when t seconds, right? The speed of the truck at t equals 10. So the velocity is going to become the integral. Will become the integral of the acceleration, which is this expression, 9t squared plus 2t minus 1 with respect to t. So integrating that, the velocity becomes, add 1 to this power, I get 3 and divide by the new power of 3. You can cancel that 9 to give me 3 t cubed. That is correct. If I differentiate this again, I'm going to get that. Then this one is going to give me, add 1 to the power, I'm going to get square over square. So this 2 will be cancelled. So I'm going to just get t squared. And then this one, integrate the minus 1 to get minus t plus a c. But here, I have to assume that it starts from rest, right? I didn't give me any conditions. I'm going to assume that the initial velocity is 0. So I'm going to assume that when t equals 0, the velocity is 0, and therefore the c equals 0. Based on what is happening here. Right? And then I want the velocity when t equals 10. So I'm going to apply the c equals 0, and also when t equals 10, the velocity when t equals 10. So when t there, when t equals 10, the velocity becomes 3 times 10 cubed plus 10 squared minus 10. And this works out to be, this is 3,100 minus 10. 3090. Let's see. It's like 3090 on my calculator. So it becomes 3 times 10 cubed. That's 3,000. Yeah. Plus 10 squared, that's 100 minus 10. Yes, 3090. 3090 centimeters per second, right? That's what it said. Centimeters per second. Centimeters per second. Right, that's the speed after 10 seconds, assuming that it must start from the side. It says find the distance covered by the truck between 5 and 10 seconds. Express your answer to the nearest whole number. All right, so what is gonna be good that will help us, or this becomes the velocity formula. This thing right here. And I don't want to assume anything, but that's a cubic curve, you know? A cubic curve like this. So we'll just get a velocity time graph, it'll be a cubic curve, we pass through the origin. So it's basically be like this. Pass through the origin. Right, so and then to have two other times when it's at rest out here. One will pass through the origin because I can factorize with a t. So you know what? I want to see how this thing move. I don't want to be just substituting values. I want to see because if you are any part below the x-axis in the region where t equals 5 and 10, it's gonna negate, it's gonna take away, subtract. So I would prefer to make a sketch to see exactly how this graph is, this graph of this function. So I can see where the 5 and the 10 is. All right, and see where I need to get the distance because on the velocity time graph, the distance is here on the velocity time graph. So I can treat it that way. I prefer to see the function. So I'm going to factorize this velocity function and write it as p equals, let's factorize it, t into 3t squared plus t minus 1. This can't even factorize. This can't factorize. Can't factorize. Nope. So to get where it crosses the x-axis, to get where it crosses the t-axis, it's going to go like this. So to get these points where it crosses the t-axis, I have to, for the t equals 0, that's that point, you know, t equals 0. I have to solve this thing equals 0. Oh boy, I prefer to see it. I'm not just on the substitute the values in there. Most people will get an expression for the displacement. Calculate the distance covered between 5 and 10. Yes, I want to integrate between 5 and 10, the velocity with respect to time to get the distance covered. I want to see where it is. I want to see where it is to make sure that no part of it goes below the axis in that region, in that time interval. All right, so I need to get the solution for this to get the root where it crosses the x-axis or the t-axis. So I'm going to solve 3t squared plus t minus 1 equals 0. I'm going to solve it to see where it crosses the horizontal axis. What is of t? So again, proper sketch and have a good look at it. So the t using the positive formula, the t is going to be minus b, which is minus 1, plus or minus the square root of b squared, and the b is 1, so it's going to be 1 squared minus 4 times the a is 3, and the c is negative 1. And putting everything over 2 times a is 3. But what at a space, but so be it. All right, this is me working out the t values. So I'm going to shift this over here. I want to see where it crosses the t-axis. All right, so I'm going to put this in the calculator. This will be minus 1, minus b, minus 1. Right here. So I'm going to write this calculator and get these two values. So I can make a sketch, see where it is. Prefer to see where it is. I don't want to just be substituting values. Because if it goes below and above the x-axis, if it crosses the x-axis in that interval between 5 and 10, then your integral, if you integrate straight in that interval, it's not going to give you the correct answer. All right, so that is it. That's just good practice as far as I'm concerned. So I got a fraction minus 1. Let's use a plus first. Let's use a minus first. Let's use a minus first here. Minus the square root of 1 squared, which is 1. This 1 squared is 1. Then this this becomes a positive 12. So it's plus 12 all over 6. All right. So it's giving me negative. Oh, so that's what happened. The partial origin, but it also has a negative root. Okay, cool. Negative 1.5. And I'm going to change this to a positive now. Yes, that's what happens. Change this to a positive, and I get 0. 0. 0.8, 0.87. So the curve really then has a negative root and a positive root and a partial origin as well. All right, so for to sketch it in red, it will basically look like this. I'm going to make all of this smaller to get space. It would look like this. So negative root, I would say, because the cube term is positive, it goes up like that and come back down. So it goes up, it passes through the origin, you know, and it passes through the origin, right? So it has 3 roots, so it goes up, passes through the origin, comes back up. So this is a negative 1.5, this is a 0, and then this is a 0.75 right here. 0.87, 0.87. This is a 0, and this is a negative 1.5. So yes, between 5 and 10, it is out here. Somewhere out here. Let's just make a sketch. Right, between 5 and 10, it will be out here, like 5 and 10. So I have to calculate the area on the graph between 5 and 10. Because that's my velocity and graph. I prefer to see the graph. Just to make sure. So I have to integrate between 5 and 10. Between 5 and 10 to get the thing. And I just wanted to see it. So let me move this out of the way and get some space. I'll make it smaller. All of this thing. That was not really needed. Make it smaller. There. All right. So then the distance I want is here under the graph right there. So that distance between is the distance between that becomes put this in a different color. It's like an analysis that we did. All right, go back to the blue for the distance. That distance is going to be the integral of the velocity between 5 and 8. That's the area I want of the velocity. And the velocity is this without the c. I'm going to see 0, you know. So it's 3t cubed, 3t cubed, and plus t squared, and then minus t with respect to t. I just don't like how they don't give a lot of space to write. All right, I just don't give a lot of space to write. They just don't. And then you have to just work this out on the next page and I'll show the answer, you know. Sure. So I'm just going to integrate and then put what the final answer would be. So the S would be, add 1 to the power divided by a new power. 3t, zoom it up. 3t to the 4th power. 3t to the 4th power over 4. And then this one would integrate to t cubed over 3 minus this one would become t squared over 2 between the 8 and the 5. All right? That's 8 and 10. It's 5 and 10. Sorry, my mistake. 5 and 10. Between 5 and 10. 5 and 10. I'm just going to put what the answer is right now. I'm going to calculate it. I'm going to do it to calculate and put what the answer is. So basically, I'm going to shift this over a bit and zoom this up. So basically, what we're going to be doing now we're going to be substituting the 10 into this whole thing for t, and then subtract, and then subtract the 5 in it again. That's what we're going to be doing. And that's the one calculation because I don't want to have space to work. So it's going to be putting the 10 first. All right. So in the first bracket, I'm going to have 3 times 10 raised to the power 4. And that is divided. No, I don't want it like that. Put the fraction first. So let's put it on. Let's put the fraction first. I'm going to put the fraction first. And then now put it 3 times 10 raised to the power 4 over 4. And then I'm going to add a fraction again, t cubed, and the t is 10 cubed over 3. And then I'm going to subtract fraction again. T this time is 10 again. This time is squared over 2. Then I come out of that and I close my bracket. That's when I apply the 10. I'm going to subtract bracket, then I'm going to apply the 5. So like I'm going to get about the same thing. Don't think I can copy this fraction 3 times. It's going to be 8 now. 8 raised to the power 4. No, not 8, 5. Why am I writing 8 all the time? No, new limit is 5 for t. So it's 5 raised to the power 4 over 4. Then I'm going to add a fraction again. And the 5 again, 5 cubed, 5 cubed over 3. And then I'm going to subtract a fraction again. And that's 5 squared, 5 squared over 2. And then close that bracket. That's going to be my answer. And they want it to the nearest whole number. So the nearest whole number, that is 7.285 centimeters. That's the distance traveled. That is it. Answer. That is it for that part. All right. I just wanted to see the sketch. So I can ensure that no part of that region goes below the axis. All right. This part now wants us to just integrate this. So this is straightforward stuff. But integrate this as a composite function. So it's going to become equal to. So you treat this as if it was x squared first. So it's going to become the entire thing. 2x plus 3. Add 1 to the power, get cubed. Divide by the new power of 3. We also have to divide by the differential of what's inside. We differentiate this equal to 2. And don't forget your plus c or plus k. Let's reduce it, right? So this becomes 1 over 6. So it becomes 1 over 6 times 2x plus 3 plus 3 cubed plus k. I put k r c and some of integration. Go on here, integrate this. Now, when we differentiate, first this 5 can come outside here. So this can become 5 times the integral of cos 2x dx becomes equal to, now we integrate cos, you get sine, or we differentiate sine, you get cos. Remember though that we also divide by differential of 2x. So when you get 5 into, what is now, I'm going to get sine 2x by the differential of the 2x, which is 2, and don't forget the c. So it actually becomes 5 over 2 sine 2x plus c. My eyes are closing. My eyes are closing. Come on, Mr. Shaw, you can do this. One more after this. That's what I'm gonna put as my answer right here. Let's try this sign better. Sine of 2x. All right, plus c. No, it's this one. If dy by x equal that and y equals 2 and x equals 0, find the equation. I'm gonna just integrate this, right? So to do this, I'm going to integrate. So let's do a little. I'm going to multiply the dx over here. Let's teach advanced students something. So dy becomes equal to 6x minus 10 times dx. I'm going to integrate both sides. So I'm going to integrate this side and integrate that side. I'm integrating this side with respect to y. But like there's a 1y there, no? So this is like there's a 1 dy there. So I'm going to put a 1 there. So like I'm integrating 1 with respect to y. Let's put that integral sign now. These are some known conditions. So when the x equals 0, you can put it here on the bottom of this limit. So that's why I don't have to calculate no c. The y is 12, and put it on the bottom of this slide over here. Y is 12. Then now I'm integrating to my general values. All right. So I'm integrating from those like initial values to my general value. My general value for x is x. On this, I'm putting x as my upper limit. And on the y function, my general value is y. So when you do it that way, you don't need to calculate the c. The c automatically calculated for you in the 12 and the 0 that is applied here. So I'm going to integrate this side. When I integrate the 1, I get y between y and 12 equals, when I integrate this side now, I'm going to get, when I integrate this first, I'm going to get 6x squared over 2, which is going to work out to 3x squared, right? That's what I'm going to get. So 3x squared for that one. So I'm going to write my 3x squared minus, integrate the 10, I get 10x between the 0 bottom limit and general value limit is x. And see, it work out itself. I don't need to calculate on c. So if you didn't know this method before, you can ask Mr. Sean what teacher now. All right, in the pure maths, you will learn this method. So this becomes, apply the y on the y, this becomes y. And then apply the 12 on the y, I get 12, subtract 12 equals. So that's how the c is taken care of. I'm going to apply the x on the function. So it's just going to become 3x squared minus 10x. And then if I were to apply the 0, everything's going to become 0. And so basically that's it. I just need to transpose this 12. With the normally, you're going to see that c is 12 just the same. So it's y equals 3x squared minus 10x plus 12. So if you do it the original way, we put the c and you substitute the values in there, we'd have got the c plus 12. All right, that is that. So end of this question. All right, nice. Make this a little bit larger. Shift this down. Make this just a little bit larger there. All right, good. All right, end of this question. All right, so I'll do the last question over here now. Last question, number 6, statistics and so on. Oh, I'm tired. What time is it? What time is it? It is now 4:40 in the morning. Oh my goodness. I'm gonna die later. All right. So see you in the next question. Question 6. Not that, not that, not that. See you in question 6. Right.